So far we've looked at this function here, f of x equals x, x here times sine of x here. So you start out by drawing your graph of y equals x and your sine of x. Well, the whole function here will look something like this. Okay, so we've looked at this function here, and then we also looked at f of x equals x squared times sine of x here, and it turns out to look, it will look something like this. It will get bigger and bigger here like this. Okay, and we also looked at f of x equals x to the power 3 times this thing here, giving you a graph looking roughly like this. It gets bigger out here, and then it gets bigger and bigger out as you move outwards. And now in this video we're going to look at 1 over x. So now we're going to look at 1 over x times this thing here. So here you've got a block multiplying a fraction. So when you times a fraction, it gets multiplied to the top. So sometimes this whole thing here can be written as a sine of x over x. You see, when you come to write it like this, it looks much neater. But when you come to analyze or try to understand what this function looks like, visualize it as this. So when you try and understand it, try to visualize it as this. But when you come to write it as this, because it looks much neater. Okay? So to really understand this function here, we start out by visualizing as this. We've got one thing multiplying this thing. Now this block here, 1 over x, is given by this graph here. Okay, 1 over x. Remember your 1 over x graph will look something like this. Okay, and we are trying to understand. So the black line here represents this block here, and your sine of x will look something like this. Hang on. Your sine of x will look something like this. So it's just it will look roughly like this. When you come to sketch this on a graph plotter, it won't look like this. I'm just exaggerating it. So just so that you get an idea of what's going on. So now to understand this graph here, it's this thing multiplying with this thing here. Now this block here just jumps between -1 and 1, -1 and 1, and so on. So suppose if you look at this block, this bit here, you see at this point here, sine of x is 1. Now 1, and then you times whatever this block is. Remember, the black line represents this block. So this 1 here times the black line is just going to take you to this bit here. So the graph here will look something like this. Okay, and then on the negative side, let me just fill this in. Hang on. On the negative side, it will look something like this. So on the negative side, this bit here is -1. Well, -1 times 1 over x. Remember, hang on. At this point here, this here is -1, meaning that this block here is -1. Now -1 times this, it will basically take you to this point here. Okay, so from here it will get moved to here. Okay, so and then 0 here will remain at 0. So your graph will look something like this. Okay, and then this point here will get moved to here. So it will look something like this. And then this point here will get moved to here. So it will look something like this. And so on here. And then if you keep on doing it, you see it's going to be like, it's going to get smaller and 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 smaller into. So it looks something like this, and on the negative side, hang on, let's just do this. On the negative side, it will look something similar to this here. Hang on. So it's going to be like this, and then it gets large. So it's going to be something like this. Okay. So your overall your graph will look something like this. It will be big at first. Hang on. It will look something like this. I'm exaggerating, okay? So when you come to sketch it on a graph plotter, it will look roughly like this. The idea is correct, but it won't look like this. When you come to do it, it looks really flat and really hard to see. You've got to zoom in to understand what's going on. Okay, well, anyway, let me just continue with this. So it will look something like, hang on. It will look something like this, and then it will get smaller and smaller and smaller, and then yeah, it will look something like this. Now, if you look at this function here, remember what a function is. A function is like a machine here. So you've got 1 over x times sine of x here. So this is like a machine. Remember that the domain is what you can put into this machine without it breaking down. So you can put the number 90 into here, 90 degrees into here, and then it will give you a value out here, whatever it is out here. But then the thing is, if you put 0 into this machine, it will break down. If you put the number 0 into here, because, okay, fair enough, if you put sine of 0, that's okay, because sine of 0 is just 0 here. But then if you put 0 into this block here, it's 1 over 0. The minute you see this, it breaks down. So the minute you put 0 into this machine, it will break down. So what I'm trying to say is that 0 is not in our domain. Remember, the domain is what you can put into this machine without it breaking down. So basically, you can put any number into here except from 0. You see, 0 is not in a domain. Whereas if you can put the number 1 in there, you can put 180 in there, you can put 90 in there, you can put any number in the real on the real number line, and the machine won't break down. It won't break down. But the minute you put 0 into here, the machine breaks down. What I'm trying to say is that 0 is not in the domain. This thing here, 0 is not in the domain. Okay, so 0 is not in the domain. But the weird thing about this function is that it looks something like this. Okay, when you get near to 0, it crosses over. So small, it gets bigger and bigger and bigger. When you get near to 0, it crosses at this point here. Okay, it crosses at this point here, and it crosses this. Well, it crosses this point here. You see, well, when you look at this sine graph, hang on, bear with me on this. I'm trying to explain a concept to you. Hang on. When you look at this point here, this is 1 times this thing here. It will take you to this point here. When you're at 1 here, you times this thing, and it will take you to this point here. Now, when you're at 0, this whole thing here, if you look at this here, if you're near 0, let's say 0.00. Remember, we can't put 0 into this thing here; it breaks down. But if you select a point just to the right of the 0, let's say 0.001, and then later on we will select a point just to the left of it, negative 0.000 whatever 1 here. So a really small number just to the right of 0. Now, if you put this into this thing here, then this whole block here will be a very big number. So here you've got a really big number, and then if you look at this here, if you put this number into here, you will get a really small number near 0, very small, very small. So here you've got big times very small. So well, you see, when you're here, it's 1. This bit here is 1 times whatever this number is. Let's say this is 34. I don't know what. So 1 times 34. That's nice and easy because it will take you to here. But when you're at 0.00001, this thing here is really big. So here you've got really big times really small. So really big times really small. Where will it be? How do you know? It might cross here, or it might cross up here, or it might cross up here. But for some reason, let's just say it crosses here. But why does it cross here? You see, at the moment, you don't have enough knowledge to answer this question. But it does cross at a point. Let's call it L for it crosses this limit here. Well, but we will explain that another time. But the important part is let's say it crosses somewhere here. Okay. Now zooming into this bit here, just zooming into this bit here, it will look something like this. Let's say you've got your graph and it crosses over here. Okay. You see, at this point here, I cannot have 0 in there. Hang on, I cannot have 0 in there. So when you come to draw this, you have to have you have to have a circle here, like this, because you cannot have you cannot have the number 0, but you can have any number just to the right of 0. So my point is that where it crosses, you've got to have a circle here to represent that, to say that you cannot include the number 0. So this function here, your graph will look something like this. But then there's a gap right there. There's a gap right there because you cannot put the number 0 in there. But anywhere to the right is okay. Anywhere to the left is okay. But you cannot have the number 0 in there. So, why it crosses here is actually very interesting. But you don't have enough knowledge as to why it crosses here. It crosses here at something like 0.017 or yes, something like this. But why at this point here? Why 0.017? Why that number? There is a reason for that, but your knowledge is not good enough. Maybe I will explain this one day. Okay.